Okay, before we delve into details with quadratic functions, I think it's appropriate to explain why quadratic functions are called quadratic. Quadratic is a term that's referring to, it's distinguishing the function from a constant function or a linear function. So let's look at a constant function first of all. And a constant function is just y equals some constant a. Okay, pretty simple. The constant function is um, either going to be um, positive constant or negative constant. It'll either be always above the x-axis or always below the x-axis. Um, it, its output, its value never changes. The value of y is always the same. That's why it's just horizontal. Okay. Well, they also have a linear function. A linear function is partly named that because its graph is a line. Now, clearly, the graph of a constant function is also a line. The difference, though, between a linear function and a constant function is the line in a linear function isn't horizontal because of this linear term. This is called the linear term with x to the first power. We don't write first power, but it's understood. But we just write ax plus b. Now, the more familiar form of a linear function is y equals mx plus b. But I'm just using a here to relate the constant function to the linear function, and then you'll see how it also relates to the quadratic function. A is just the same thing as m in this case. A is your slope. And if a is positive, what's the line going to look like? If a is positive, then it's going to be going upward. If a is negative, it's going to be going downward. Just like if this a is positive in the constant, it's above the x-axis or below the x-axis if a is negative. Now, this term is, well, you know it's the y-intercept. It's the same b as in mx plus b, but he is the constant term because he's a term that doesn't change. This term would change depending on the value of x. This term is constant. But the real reason that he's the constant term is because he's the x to the 0 power. Remember, x to the 0 power equals 1. And this is ax to the 0 power. So we've got ax to the first plus bx to the 0 power. That's a linear function. A constant function is ax to the 0 power. Now we don't write that. We leave it out, and we leave out the 1, ax plus b. But we understand that this is the first power of x, and technically this is the 0 power of x. Okay? Now let's talk about the quadratic function. The quadratic function has an x squared term called the quadratic term. That's what quadratic means. Quadratic really means squared. And it's not something about Latin for square, quadrant, but anyway. You might think quad means 4, but quad, if you think about it as a square unit, then quadratic makes sense. Square is one of the basic quadrilaterals. So anyway, quadratic term, and I guess hopefully you can guess what this is. This is the linear term, and this is the constant term. What power of x does the quadratic term have? 2. What power of x does the linear term have? 1. What power of x does the constant term have? The 0 power. But he's invisible. You don't write x to 0 power. He equals 1. Okay, so I'm just going to take him out of the picture. So it's ax squared plus bx plus c. Now this is the standard form of a quadratic function, and there are other forms as well, just like there are other forms of a linear function. There's this is slope-intercept form, sort of. This is intercept form of a linear function. Standard form is ax plus by, ax plus by equals c. Anyhow, now quadratic function can be either positive, quote unquote, or negative. The positivity, negativity of any of these functions is determined by the sign of that leading coefficient. The sign of a tells us whether the function has positive attribute or negative attribute. Well, you don't refer to the function as positive or negative, really. I should have quotes around this, um, and I do up here. This is not a positive linear function. It's a linear function with positive slope. But we think it has a positive attribute. The primary attribute of the linear function is its slope, and that slope is positive. The primary attribute of a constant function is whether it's positive or negative. Okay, now, the positivity or negativity of the quadratic function is also determined by whether a is positive or negative. If a is positive, then the quadratic function, which is always in this shape, which is called a parabola, the quadratic function will be opening upward. And if the a is negative, the quadratic function will be opening downward. So there's a correlation between this a and this a and this a. It always determines the positivity or negativity of the function, the attribute. Okay, now that's a quick introduction to why the function is called quadratic and how it distinguishes itself from the linear and the constant.